How are you doing? My name is Eduardo Reina and I'll be doing the problem 10.9 from the chapter 10. In the problem 10.9, the book gives us some condition as shown currently in the display. Once we have this data arranged in Excel, we must add another column called identity in order to use the method of fitting the model. Now let's get to work once we have these tables. In order to get the X transpose, the data we'll be using is the identity column and the two natural variables as well. Due to the matrix being a 3 times 8, we separate a space of 8 times 3 and use the formula transpose from Excel. Select the X matrix and hit Ctrl Command Shift and Enter at the same time. Now let's calculate the missing matrices. X transpose times X is the product between both matrices, resulting in a 3 by 3 matrix. Thus we separate a 3 by 3 space and use the formula MMULT, inserting the matrices in the correct order. Afterwards, we separate a 3 by 3 space and use the formula inverse, selecting the previous matrix in order to get the inverse. In the case of X transpose times Y, we do exactly the same as X transpose times X, just instead of getting a 3 by 3 matrix, we obtain a 3 by 1. And at least, to get the betas, we multiply the inverse of X transpose times X by X transpose times Y, giving us a 1 by 3 matrix. Now that we have this format, we can use it to solve the other cases and start responding the given indents. First, letter A is the matrix of X transpose times X, and in letter B, we concluded it's indeed a diagonal matrix. In letter C, they ask us to change the natural to coded variables with the next formulas. Once we get the coded variables, we replace the data on the Excel and get the X transpose times X matrix. To see, it's a diagonal matrix as well. On indent D, we do the same as indent C. We change the natural variables to coded with another formula. We replace again the data in the Excel to find over again that the data behaves as a diagonal matrix in the X transpose times X matrix. Once done these 4 indents, the problem is definite. We can see that the coded variables, depending on the value they have, they change their sum of squares and their respective interaction with the identity in order to get the betas.
Created using Powtoon.